Hi everyone, this video will go over how to use Karamba. The first thing you need to do is pull a license and open a blank Rhino document and type Karamba with a K, K-A-R-A-M-B-A, 3D get license. This will pop up. And if it is licensed successfully, you will see some text up here. It may take a few minutes, not a few minutes, but maybe 30 seconds. Rhino might freeze during that time while it pulls the license. If you get an error, so the first thing you want to do is type Karamba 3D get license. You might possibly get an error. And the error that you will likely encounter is you are not currently logged into an account. Do you want to log in? Select no. And then a little window will pop up that says Karamba 3D needs a license. Click I have read the license policy. Then click use the zoo. And you want to use the zoo with the following host name or license address. And then you want to point to this license. So this is COEIT-LICENSE01.coeit.osu.edu. And this should point Rhino to the license, and at that point you should get success. If you do not get success, then there's something going on that ETS needs to fix. So please send ETS a ticket, and if the Karamba cannot pull a license down in the studios, let me know. All right, so let's assume now we are starting from a point where we have Karamba licensed. We've typed Karamba 3D get license. Now we are licensed. It seems that for some reason the license is very finicky when it's installed over a license server. So it's important that you always open a blank document first and then start working, and then pull in a document that you are interested in working with. What we might also want to do now that we have, before we open a document, now that I have the license started, I am going to go ahead and open Grasshopper. So Grasshopper is loading up. And here I can go to Karamba. I can find Karamba 3D at the top. Select that, and then I can check the license, the status of the license by, once I've clicked on the Karamba tab, I can go to the left, click the Karamba license, and I can drag that down. So left click and drag the license down. And if it's orange, something is wrong. But if it's gray, we're probably okay. So I'm going to link up a panel to this. I'm going to do this by double left clicking and then typing panel. I have a panel, and then I can pull a wire over from the license file. And now I can see that I actually have a license. Now, if something's not gone, if the license is not active, you'll get a different message here. But here we're saying everything is good. So it's not a bad idea just to double check the license when you first open Grasshopper. So the step is to, again, get the license going, then start Grasshopper. And now we could start from scratch, or we could open an existing file by pulling it in. Now, if we're starting from scratch, it's really important that if we type units and double check that our units are in feet. So you don't want to be in inches. This has to be in feet in order for Karamba to work. So now we have, again, if I type units, now we're set to feet and everything is good. And we could start making a wireframe for our bridge. But let's go ahead and look at the example files that are found on Canvas. So if you go to, let's see here, hold on one moment. Okay, so in the modules page, we can find the TrustBridge project assignment overview. And if we click that, you're going to see a number of files here which you can download. There's a simple example and then a full bridge example. So let's just quickly review the simple truss example again. And there's a 3DM, so that's the extension for a Rhino file. And then there is the .gh, and that is the extension for the Grasshopper script, also called the Grasshopper definition. And we have the same for the full bridge. We have a sample truss bridge with the model of the testing frame, and then we have a .gh Grasshopper definition for the sample truss bridge. So I have, so you can just download those by clicking these down arrows. I saw some of you clicking the name, and then that will pop you into this like slightly more confusing interface. So it's best just to click the down arrows to download. And once we have those downloaded, I already have those downloaded to a file here. Or I thought I had them. Hold on one second. Let me find them to a folder. All right, I found them. And we have the Grasshopper files, and then we have the, and then let's just sort these by name. All right, so that's how it's gonna, let's sort them by, yeah, name's fine. So, okay, so we have the simple Karamba truss example. Let's start with that. So I'm just going to pull that over, and let's just open this file now. Save changes to untitled, no. Okay, and you can see that we have a series of very simple trusses. Let's just now launch Grasshopper again. Grasshopper is still active. I'm double checking the license panel. Everything looks good because it's gray. And if I zoom in here, we can say that, okay, cool, I'm good to go. All right, so that is, so we could build the script from scratch, but let's just go ahead and use one of the scripts that I have. And to open that script, we're going to want to open Grasshopper. Or you know what, actually, I can close this, and then I can just grab the simple truss example and drag this in, and it should just open right up. Now, okay, sample truss, again, Rhino units must be set to feet. This is very important. And so I could just, now that I've opened this file, double check this, units set to feet. So we're good to go. And let's now go back to Grasshopper. Now the thing is that if you click the X here, once you've initiated Grasshopper in Rhino, it doesn't actually close it. It just hides it. So until you close down Rhino, Grasshopper is going to be running in the background. So you can either minimize it or you can click it off. So don't freak out if you start setting this up and accidentally close this, because even if you haven't saved the script, you can just type Grasshopper and get back. And of course, you can also minimize it. And then if you type Grasshopper, it should pop back up as well. All right, so there are these components, and the way that Grasshopper works is that we can either build things from scratch, or we can pull in elements, geometric elements from the Rhino 3D model space. So in this case, you know, I'm coming over to parameters, and I have all of these different parameters that I can pull over. And the way that I can reference something from the Rhino space is by, I can do it a couple of ways. Let's say I'm doing multiple points. I can shift, or let's see, shift and select these multiple points, and then I could right click, set multiple points. I'm sorry, right clicked this point component, set multiple points, and that worked. If I just want to set one point, I can right click this, set one point, then it's going to pop me over to the window, the 3D model window, and or whatever tab you have open, could be perspective, could be the top, could be the front. We're going to click the point and then we're good to go. So now let's clear that value. Same with lines or curves. I could set one line, select that line. Oops. Let's see. With a line, set multiple lines. I use set multiple lines, but oops, line, set one line. It looks like it wants me to draw that line. And now it should be there. Yeah, okay, cool. And I still only have one line in here, so that's good. Kind of weird that it asks you to redraw it, but nevertheless, okay. Now what would happen if I selected a, so you can see we have nothing in our point component here. If I left click this line and set one point, it's not going to allow me to select a line, right? Or if I select a bunch of lines here and set multiple points, it's not accepting those. So you can't put things in the parameters that are not the so-called data type that it wants. So these are all of the things that you can accept in. A brep is for poly surfaces. We won't be using that, but nevertheless, if you work with Grasshopper in the future and you want to know how to get in poly surfaces, you could use the brep. All right, so let's look at our example here. We have loads, and we need all of the ingredients that we would use to, I'm going to go to so I have some 3D trusses here, and I have some 2D stuff here. I'm sorry, I have a 2D truss and then some 3D trusses. I'm going to start with this 2D truss, and I'm going to look in the front view just because it will be easier to select the elements for this 2D truss. All right. So we need to put in all of our elements. Now, this is really important, especially when you start modeling the framework for your truss bridge. Just like a truss that uses the method of joints, we need individual elements here, right? These things cannot be continuous. So for example, the model will fail if I just have a line that's drawn from this point to this point without it being two segments, right? It needs to be two segments here. So if you draw things as polylines, just make sure you explode things. Another really important command is SEL dupe. So that's for select duplicate. So cell dupe. And no duplicates found, nothing is added to the selection. That's good, but what cell dupe is looks for things which are overlaid. So let's say I had this line, Control C, Control V, I copied it on top of itself. So now I have two lines here. SEL dupe will find the duplicate and I can hit delete, and now I should be good to go. And that's useful. All right, so the first thing we need to put in is the so-called beams. Now we know that the individual members of a truss don't work like beams. They work like axial members, either in axial compression or axial tension. But nevertheless, Karamba refers to the wireframe that it analyzes as beams. So we're going to just select all of these things, right-click, set multiple curves. And you'll notice that when I select this, it doesn't go green. So when you put something in a parameter box in component in Grasshopper, when you select it, it'll go green, but only if it's visible. So I'm going to right-click this parameter and put preview. And now you can see when I select this, it goes green. And this tells me that I have everything in there. Now, when I drew my selection window here, I included the points because I knew that the curve component would not accept those points. So it just grabbed the lines. So I'm not going to right-click this and hide the preview again. So I do this by turning the little preview guy off here. And that way, when things start to happen in down the line, like because each time you move from one component to the other, it copies the data that you have in here. So these lines get kind of copied down as we go along. And then it gets a little confusing. So it's good to sometimes hide things as we go along. So we have the curve component connected to the line component here, and then we have a modify element. This is where this component is good for turning on and off bending. So we have bending false because ultimately we want frictionless pin behavior at the joints. So if we turn bending on, it's going to behave more like a welded frame. And if we toggle false on, it's going to, the joints in our truss will behave more like frictionless pins. Okay, so now we want to add some support points. So I'm going to go ahead and let's put our hinge on the left-hand side and our roller on the right. So I'm going to right click point, set one point, and I'm going to select that point as my hinge point. And you can see here that something has appeared. So it's already starting to put together the model. And so let's just look at the support component here. Point is going into position or index. So the point tells us where the hinge is going to be located, and it's going to be located wherever that point is. So that it's important that point is exactly at the joint between these two lines, or all of these lines. The condition, so how do we know this is a hinge? Well, every time we click a button here, it is restraining an axis. So it's restraining the translation in X, it's restraining the translation in Y, and also in Z. Limiting the rotation, restraining the rotation in X, but it's allowing it to rotate around Y and Z. And so if we think about where the Y-axis is here in 3D, it's going this way. So the Y-axis, if I were to draw a line, is like that, which means that our truss could spin around that line, and that's fine. Now the Z-axis is like this, going up and down. So it can freely spin about that axis. We could restrain that, but there's not really going to be any force on that direction. So we're just going to leave that unchecked for now. All right, so now let's go back to our front view, and you can see here how it becomes harder to see our wireframe once things start appearing based on what's happening in the Rhino definition, in the Grasshopper definition. So here I could begin to, hold on, it looks like Grasshopper is frozen for a second. So I'm going to pause the video and fix that. But what I wanted to show you basically is that we should be able to, hold on, maybe I have a command going. Do I have a command going? Click this? No. All right, so I'm going to close this and be right back. Okay, I'm back. All right, if I scroll over here, let's say I want to hide this, I could go to the beam view, and let me go back to the front view here. So the issue is that maybe I can't see my wireframe, so I'm going to come to the beam view, right-click this, click preview, turn that off. Now I can see my lines again. Okay, cool. So now I'm going to right-click this point and right-click, set one point, and now I've set up my roller. So now I have my roller. Now we need to, let's turn our beam view back on. Okay, and the only thing missing is what is in orange here, and this is our point load. And we are going to, I know that that point is there, so I'm just going to drag a box, and then I'm going to set the point load at this location, and I'm going to right-click point, set one point. Okay, cool. So what's cool now is that we're actually seeing something happening. If we go to the left of the load here, we're going to look at, I have a slider here, loads in pounds. So whenever we put a number in Karamba and attach it to the load component, it's going to assume pounds. Now, I'm sorry. It's going to assume kips. So if we put a force in here, let's say if I had like 1,000, this would be 1,000 kips, not 1,000 pounds. And it's actually sort of doing that. Oh, broke my bridge because I need a vector. There we go. And you can see that, okay, it's like totally gone crazy. And that's because we've put this like super high load on it. So if you want to work in pounds, which might be a little bit more intuitive, we need to use a division component. So we just get that by divide or division, right? And we can divide one number with another. So we have our slider, which we're going to call pounds. And then we divide this by a negative 1,000, and that dividing it by 1,000 converts it from pounds to kips. And then making it a negative 1,000, the negative points us down, because we also have to, when we have our force, we have to have a position to apply the force, but we also need a vector. So I use this little unit z vector, since we are in 3D space. Pushing down is going to be down in z, so we want to go down in negative z, and we have this negative 1,000. Now we connect so if we want to see what's coming out here, use a panel. The panel is going to be going into, so we've got our load in pounds. We're going into this component. We're dividing it by negative 1,000. And so what comes out is negative 5.543 kips. So 5,543 pounds becomes negative 5.53 kips. Then we need to give it a direction. So we use this z vector, and voila, we have 5.54 kips pushing down. And if you wanted to see this, see the value, you could always stick a little panel here in between, and you can see how it's being converted from pounds to kips. You could even give this a little name here by right-clicking the panel at the top, typing kips, and now we know exactly what's happening here. Okay, cool. So now as I slide this to zero force, right, nothing's happening to the truss. And as I slide this back and forth, right, or as I add more load to it, it deforms more. What's also nice is I'm getting a visual representation of what's in tension. Sorry, what's in tension is in blue. What's in compression is red. And then our zero force members, or they might be very low force. Sometimes this is a very pale pink or a very light blue, but these seem white in color, and so that tells us that these are zero force members. And that makes a lot of sense given where the load is, right? Now let's say we change the position here of the load to this lower point, set one point. Now you can see that we actually have more zero force members than before, which is perhaps a little unexpected, but nevertheless, we've moved the load. Now we could select this point and this point, right click, set multiple points. Now we go back to kind of what we had before. And, we could also put point loads here. We could, let's say we put a point, let's put a point load here and here. Set multiple points. Okay. And you can also see that there are arrows appearing here showing us where the forces are applied, which is very helpful. Okay, so I'm going to go back to the simplest case, which is just to set one point right there. So we're applying our point load right there in the middle of the bridge. And so you can see that we have a hinge, we have a roller, and it is moving as we add more load. So this is just showing you not exactly how much it would deform. I mean, you wouldn't really see deflection, hopefully, if your structure is stable. But if we go over to the render settings here on the model view, so we come over to the middle of the script, pass to analyze, and then look at the model view, there's a deformation scale. So we could slide this to 0. We're still seeing tension and compression, but we're not seeing the movement. And the deformation is basically just allowing you to exaggerate the deformation to show you how the structure would tend to move if it moved, right? Now, let's assume that this is a stable structure. It would actually be like this, right? And if it broke, if it collapsed, it wouldn't necessarily just do this and collapse. It might break a specific joint, for example. The way where it fails might be unpredictable. But in terms of how the deformation is tending to move it, we can exaggerate that scale here, or we can click this off altogether and not see it, or take it down to 0. Now, the other thing that we might want to do here is sometimes you can't, this might be, oops, sorry, my slider is on the other screen. Sometimes you might not have enough magnitude here to really show the deformation. And so if you double left click this number, where did it go? Then if you double left click the number, then the slider control will come up and you can give a larger maximum value for that. So you can exaggerate the deformation. Okay, cool. So now we've got quite a lot happening. If I go to the perspective view, I can see that we have some sort of image for a cross section here. Now, what we want to do is so right now we have our flange width. How do we control the cross section? We have another slider here that's controlling that cross section. You can see that as I make it smaller or bigger, the bridge is deforming more or less. And the way I'm making that cross-section is with this cross-section component, which is a Karamba component. I've got it set to trapezoid. And then I've plugged my slider into all of the values that are, so actually if we click this, you can see that we can change it from trapezoid to other types of cross-sections. Trapezoid will probably be good for your basswood. Now I'm using a square, I turn it into a square cross section by using the same value for all of the inputs here. But I could make a, let's say, a rectangular profile by changing the height here. So now I'm getting, let's say, a taller height, but a skinnier width, for example, right? So I'm getting this irregular profile. So trapezoid is good. It gives you quite a lot of flexibility to get rectangular shapes. Let's go ahead and I'm just going to plug this back into all of them. Now you may want to, so one of the cool things you can do here, so this is the flange width in inches. Now this particular model, if I measure the distance here, this is more at real world scale, not little bridge scale. And so we have 60 feet here. And so I've got like a 12-inch cross section here. Now your cross sections will be much lower than that. What's nice about this is if I click the deformation off, right, it's based on the cross section using this component beam view, actually modeling that geometry for us. And now I can, it's modeling it as a mesh, geometry. I can bring a little mesh parameter out here, right? And plug that into this, right? I already have that set up and I have it turned off so we don't have too many of the same things being shown. But if I want to capture this information in our, so if I close Grasshopper, so just close this, all of the, everything that we're looking at disappears, right? And when I turn Grasshopper back on, then it reappears. If I want to put this geometry that's being generated within Grasshopper into the model view, all I need to do is right click this mesh and there's a little command here called bake. Hit OK. And now if I close Grasshopper and then we go to the shaded view, I have baked this information in and I have these meshes. Actually, let's just sell mesh. Gets all the meshes. I'm going to drag this over here so I don't move my line weight. Okay, so this is cool because it actually allows us to show the colors. And I could do maybe a rendered drawing or even just this drawing or a screen capture with a white background. So for example, to make certain drawings, maybe what we want to do is if we go to options in the, let's see, the view, display modes, shaded mode. In shaded mode, I could change my background from use application settings to a solid color. Make that white. Right, oops. I must not have said okay. View, display modes, shaded. Solid color. We want it to be white. Okay. Now I need to calm down here, make sure that I hit okay. Now this is white. Grid. I could turn off show the grid, no, turn the grid off, move this someplace, and then I could begin maybe, we could, let's see, file, print, what's it, display, capture to, view capture to file. So view capture to file, and that would allow me to export. Capture the file. Oops. What's happening here? I had to escape. I probably had a very high resolution set. But you can use view capture to file or screen capture to file. For example, screen capture to file. Save it as a JPEG. Let's go back to Dropbox. Put on the, no, a desktop's kind of crazy, but we could just give this a file name, and then we could save this image. And view capture to file will give you a slightly options for making a higher resolution. So something like this could be useful. Okay, so now let's say that we want to turn this into NURBS geometry. I could type mesh to NURB. Slide this out. I'm sliding the mesh away. Now I have NURBS. I could turn off the poly surfaces here, and then I could cap these, and then I have these closed solids. And that's really helpful because if I type volume, and then I can set the units for the volume, maybe I want square feet, maybe I want square inches, I can get the volume of this, and that could be useful for doing a weight takeoff. All right, cool. So that is the basic here. Let's go back to Grasshopper and Karamba. Look at a few more things. So I'm going to turn off the beam view, which is showing me the geometry. And what you can see here is that the model view component is giving me all of these numbers, and these numbers correspond to the element tags, and each beam is considered an element. We start counting from 0, 1, and go all the way through. I think we have 8 elements total in this. And those then at the very end of our script, we convert back from kips to pounds, and we convert from kips back into pounds, and then we have these axial forces in pounds. And if we want to know how much force is in a member, we have to look and see, okay, 0 in this member, or this is member 0, it's a 0 force member. Member 1 has negative 1700. And so let's just, if we look at this beam res force, let's see here, the normal forces, okay, the normal forces. It says here, compressive forces are going to be less than 0 and tensile forces will be greater than 0. What this is telling us is that it just assigns a compressive force a negative number, so we know that it's in compression, and the positive numbers here are tension members. So that's how we distinguish, looking at this list, between tension and compression. So member number 1, that's in compression. Member number 3, that's in tension because it's positive. 5 and 6 are in compression, and so on. Then we have a bunch of zero force members. And if we turn on our beam view again, right click, preview that. Okay, cool. That's corresponding to what we're seeing. So we can see these numbers and the beam view simultaneously. Now, when you do your report, you're going to want to get this information and put it into InDesign. So you can do that by right-clicking the panel and copy all content, I believe. Should copy the content to the clipboard. So I'm just going to come here to this Word document, paste this in, and now you can see that I have all of this information here from, let me make it a little bit smaller, boom, boom. Right, and so then I could use this to make what I need to make in the InDesign document to show all of the members. And when you're looking at the critical members, you're going to be thinking about the ones that have the highest positive value, and which would be your highest, your members which are experiencing the highest tension force, and then the lowest value, which would be the high, let's say the so-called highest negative numbers, largest negative numbers, and those will be the members that are experiencing the most force in compression. So you'll want to look for those. Why don't I just, let me close this now. Now, I could just show you briefly, maybe I'll conclude this video by, let's go back to Grasshopper. How does this work for something that's in 3D? It's largely the same. It's just going to be that I'm going to be in the 3D view. I'm going to select all of these things. I'm going to come back up to beams, right click, set multiple curves. Before I do that, let me show you one thing. Again, it's really important. Everything is an individual line. And then also, all of those lines have to touch very precisely. My structure will break if I start moving these things away, right? Let me go back and turn the deformation on because we're missing deformation here. There's deformation. Okay, if I move this thing away, you can see the whole thing breaks, right? Now certain things might, yeah, the whole thing breaks. So if you're getting bad results, it's usually because you have member, or if I join these members, for example, it's going to break. Well, it didn't break because it didn't actually need those members because they were zero force, but let's join members that we need. Let's join this one and this one, join. Now you can see the whole thing breaks again. So you have to have individual segments, and the things have to touch. So you have to make your wireframe very carefully. All right, so let's move to a 3D example. Mostly going to be the same. I'm going to right-click all of these things and then set multiple curves. Okay, that changes over here. Now things are not working. Okay, now I have to select 2 points on this side. So I'm holding down on Shift, selecting both of those points, right-clicking and setting multiple points, setting those to be my hinges. Now I'm going to select that point and that point, right-click, set multiple points for a hinge. Oh, I'm sorry, set multiple point. I just moved it. Set multiple points for a roller. Let's go back and then make these points the hinge, set multiple points. Okay, now I've got our hinge. And then it's still not working because the load is over here. So let's say we're going to apply the load to these 2 points. Right-click this point, set multiple points. Okay, now you can see we're working. Cool. And as I slide the loads, this thing is moving around. So everything's working very nicely. But one thing to point out here is that, okay, so we're converting to kips. We've got now 2 locations for it. We've got 2 hinges, that makes sense, 2 rollers, that makes sense. How much force do we actually have on our object? Well, we are applying the force at these 2 points here. And basically, we've got a force input, and then we've got 2 points here. It's going to apply this force to each of those points, right? So it's not negative 2.83 kips total. It's 2.83 applied to each of these, right? So that's important to know when you're setting up the loads on your bridge. So if, let's say we wanted 2.833 total, we could do a couple of things. We could just say, okay, this is what we want the total load on the bridge to be. Let's move this over. Let's use another divide, division component. Here's division. Boom. Oh, we need to divide it by a number. Let's divide it by, let's just make a slider. So I'll make a slider 2. So we know that we have 2 points here. Boom. Okay. And now, oops, we don't want 3. This has to stay 2. And now it's dividing our total by the number of points of application. We could get a little trickier here, and this is where Grasshopper can get really fun for those of you who are inclined for these things, but we could actually look at the length of this list. So list length, and it's giving us, so basically it's looking in, if I put a panel here, we can see that we have 2 items in this list, and this little list length component measures the length of a list. And so we know that we have 2 points, and we could stick that in here, and that way we will always have the right number of points. So if we wanted, let's say we started applying this load, let's turn off the beam view, cross sections, beam view, let's turn that off for a second, preview off. This is where it gets really confusing when you have like lots of things on. So I'm going to even hide the model view preview, turn that off. All right, so let's say we wanted to spread this load across 4 joints in the truss. Now I'm selecting all these joints, coming back to where the load is being applied, set multiple points. Now we've got those 4 points. Now we've got 4 points. The length here is now coming out as 4. So we divide this number by the length of the list. And now if we go back and turn on our model view, preview, and our beam view, preview, turn that back on, we're going to see that we have, that's kind of hard to see. Let's turn off the beam view, preview. Right, you can see now the arrows. We've got 4 arrows in being applied. Come back to me. Rhino. There we go. Cool. Now we can see that we have these arrows going down, and all of those loads are applied, and we are good to go. And then if we just update these by, oops, zoom Z selected. Okay, cool. And I'm close. Let's go back to maybe just these 2 points. You'll see that these arrows will disappear. Set multiple points, and everything updates very nicely. All right, so let me just go back to the beam view. Bump. Preview. Cool. All right, so this is just to say that just remember, like when you start applying loads in 3D and you're using multiple points, so you're imagining like how your bridge will be loaded, and you're selecting points, and you're thinking about, okay, you're starting with a 50-pound load total. Just make sure that you're either dividing that load up and putting in the appropriate number, or using a division component to divide the total pounds that you're applying to the bridge by the number of points of application. So there's several ways to do that, right? And then because each value that comes out of this vector component is going to ultimately be applied to the every point that you have specified. All right, so I hope that's clear. If you have questions, send me an email. Have fun with Karamba. Once you get the license going and you understand the basics of how Grasshopper works and the basics of how Karamba works, it's a lot of fun because you can interactively test different configurations very quickly, and using this little script, see the forces that are happening in the members, and everything is just automatically updated and calculated for you as you interactively slide things around and change your design. So have fun, email me with questions, and that concludes this video. Thanks.